Hey guys, it's Mr. Davis. In this video, we're going to talk about finding the distance between 2 points by using the Pythagorean Theorem. And I got two big hints for you as we go into this. Big hint number one, draw the triangle. That will make a huge difference for you. And big hint number two, you want to write down your work. We show our work in the Pythagorean Theorem because it prevents us from making mistakes. It matters. Let's get to it. So here is our first problem. This is not going to be a very difficult problem. This is so I can explain the idea going on here. If I told you to find the distance between the two red dots, could you? Well, sure. We don't even need to know what the red dots are. I can see that these dots are lined up perfectly with each other. And I can draw an up and down line that connects them. In fact, I'm going to call that line a vertical line. And I can just count. Oops, sorry, let's make that a little smaller. And I can just count. I go up 1, 2, 3, 4. I have to count 4 spaces up. The distance between those two red dots is 4. In fact, I can do that with any dots that are lined up perfectly with each other, either by going up and down or left and right. So let's find the distance between these two blue dots. Well, I can see that they're lined up, so I can just count. 1, 2, 3, 4, 5. Do you see how I did that? You see if you can find the distance between these two green dots. Ready? What's the distance between those two dots? Go ahead and hit pause, and when you're ready to check your answer, hit play. Well, did you get 3? You should have. 1, oops, let's make that black, it'll be easier to see. 1, 2, 3. The distance between the two green dots is 3. That's the basic idea here, but now we're going to step it up a little bit. And instead of looking at dots that are just directly across from each other vertically or horizontally, we are going to look at dots that are now diagonal from each other. Take a look at these two black dots I'm drawing. Those are diagonal from each other. So how do we find the distance between the diagonal dots? Well, let's do one together. Here's two red dots. I can go ahead and connect. I can draw a line between them. Right here, I can draw my line, and I want to figure out how long is this line. And I can figure that out by calculating the horizontal distance and the vertical distance. We're going to start with the vertical distance. How far up do I need to go before I'm at the same height? Well, and it's 3. Do you see that if I raise that red dot up 3 spots, I'd get a dot that's lined up with the other red dot? So it's 3. My vertical change is 3. I need to go up 3 spots. And how much to the right do I need to go? Let's see. 1, 2, 3, 4. I need to go over 4 spots. Oh my goodness gracious. Do you see it? Do you see what I just made? I just made a right triangle. 3, 4. My hypotenuse is x. The distance between those two dots can be figured out by finding the length of that hypotenuse. The diagonal line is the hypotenuse. So let's do it. 3 as a square plus 4 as a square equals my hypotenuse as a square. 3 to the power of 2 is 9, plus 4 to the power of 2, which is 16, equals x to the power of 2. 9 plus 16 is 25, equals x to the power of 2. And let's see, take the root on both sides. That goes away. X equals plus or minus 5. Because it's an even power, I'm going to get 2 answers. Now, can I use the negative answer? No, because we're talking about length. How long is that line? And that line is 5. Those two dots are 5 spaces away from each other. Next problem, see if you can figure out the vertical change and the horizontal change, the up and down change and the left and right change. And then maybe you can even figure out the distance between these 2 points. I will go through the answer in just a moment. Hit pause, then hit play when you're ready. All right, guys, let's see what we did. First thing I'm going to do is I'm going to find out the vertical change, or how the up and down change. When I look at this red dot up here, I see that it's way up here. This is the height of that dot. So I need to find out where this spot is compared to my dot. I need to raise that dot up. So I'm trying to get way up here so that I can see how, ooh, not right there. I didn't go up enough, did I? I'm trying to go, not there, I'm trying to go way up here so I can see how far away those dots are from each other. So how far is this? What vertical change needs to happen? Well, let's see, I need to go up 1, 2, 3, 4, 5 spaces. So the vertical change there is 5. How about horizontally? I'm right here. I need to get over here. How much horizontal change is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the horizontal change is 12. Vertical change is 5. Horizontal change is 12. Does that matter? Absolutely. Because if I were to make this a right triangle, I can see that I got 2 legs, 5 and 12, and my hypotenuse is the distance, x. So 5 as a square plus 12 as a square is going to equal x as a square. Well, 5 times 5 I can do pretty easy. 5 times 5 is 25. 12 times 12 I can do pretty easy. 12 times 12 is 144. Leaving me x to the power of 2. 25 plus 144 is 169 equals x to the power of 2. The opposite of the power is the root, so I'll take the second root on both sides, and that's going to go away, and I get x equals plus or minus 13. Can I use a negative 13 though? No, because this is length, so I'm only going to keep the positive answer, and x equals 13. 13 spaces apart. That's how far away these two red dots are from each other. That's 13 spaces. Alright guys, why don't you see if you can find the distance between these 2 points, and when you are done, hit play and I'll go through the answer with you. Okay, here we go. First thing I'm going to do is I'm going to find the vertical distance. When I look at that vertical change, I've got this red dot way up here. I need to lower it so that it's down here. That way it's even with my other dot. So my goal is to get that red dot down there. Well, how many spaces does that need to move? Let's count. It goes down 1, 2, 3. Down 3 spaces. So I'm going to use a negative to show that I'm counting down. So I went down 3 spaces, negative 3. And that's actually going to work out just fine with our math. I'll show you how it works in just a moment. Let's go ahead and look at this horizontal change, the left to right change. I'm right here now. I need to get over there. How many spaces do I need to count? Let's see, I count 1, 2, 3, 4 spaces to the right. Counting to the right's positive, so that's positive 4. And we can see the right triangle right there. And so my missing value is x. Looking at this, I've got a negative 3 to the power of 2 plus 4 to the power of 2 equals x to the power of 2. Did you notice anything weird I did there? Yeah, I put that negative 3 inside parentheses. The reason I do that is because the order of operations tells us to take a power before multiplying by any positive or negative signs. It's kind of weird to think about, but the negative 3 to the power of 2 without parentheses means negative 3 times 3. Negative 3 with parentheses to the power of 2 means negative 3 times negative 3. You must put parentheses around that negative. Go ahead and you can experiment in your calculator if you want. Negative 3 to the power of 2 without parentheses is negative 9. But if I type in parentheses negative 3 power of 2, I would get positive 9. The parentheses have to surround that 3, and the 2 goes on the outside of the parentheses. So let's finish this up. Let's see, the group negative 3 to the power of 2 becomes positive 9. 4 to the power of 2 is 16, and that equals x to the power of 2. 9 plus 16 is 25, and that equals x to the power of 2. The opposite of a power is a root. Take that second root on both sides. That goes away, and I get x equals plus or minus 5. We're only going to keep that positive version. I know I just used a negative length to show that I was counting down. I've got a reason for that. And because we're not talking about a real-world problem here, it's completely fine for us to do that. But that 5 is the answer that I'm looking for. The distance is 5. See if you can find the distance between these 2 points. When you're done, hit play to check your answer. Okay, here we go. I see this dot. I want to lower it so that it matches up with my other dot. So it needs to go over here to this spot. That's where it needs to go. So I'm going to go ahead and mark that spot to help me count. And let's count. I go down 1, 2, 3, 4, 5. I went down 5. So I've got negative 5 there. And now let's count over to the right to see the horizontal change. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My horizontal change is 12. And we can see the right triangle forming as I connect those 3 spots. There's my right triangle, which means my hypotenuse is the missing value. So let's finish it up. My first leg is negative 5, so negative 5 to the power of 2, remember the parentheses, plus 12 to the power of 2 equals x to the power of 2. Negative 5 times negative 5 is positive 25. 12 times 12 is 144, and that equals x to the power of 2. 25 plus 144 is 169, equals x to the power of 2. I take the root of both sides. Let's make it a second root. That goes away, and I get x equals plus or minus 13. Now, because this is a distance, I'm always going to keep my positive answer only, and x is 13. Good job, guys. Let's have you find the distance between these 2 points, and I'll give you a hint. The answer is irrational. Go for it. Hit play when you're ready to check your answer. All right, I got this dot. I need to raise it up in order for it to be on the same level as my next dot. So my dot needs to get raised up to this spot right there. How much does it need to go up? It goes up 1, 2. Because I'm counting up, that's a positive 2. And then left and right change. Let's see. It counts over 1, 2, 3, 4, 5 to the right. Counting to the right is also a positive change. So here's my right triangle. Beautiful work there, guys. Right triangle. And I've got 2 legs, a 2 and a 5. So my missing side is a hypotenuse, and it's worth x. And I've got 2 to the power of 2 plus 5 to the power of 2 equals x to the power of 2. Let's see, 2 times 2 is 4. 5 to the power of 2 is 25, and that equals x to the power of 2. 4 plus 25 is 29, equals x to the power of 2. And I take the second root on both sides, and I get x equals a plus or minus. And let's type this in my calculator. Control hat, 2, arrow to the right, 29, enter, and I get 5.38516. I'll stop there. Now that feels really clumped to me, so I'm actually going to rewrite it right here. I got a plus or minus 5.38516. And we're going to use every single digit that that calculator gives us. Because this is an irrational number, I also know that those numbers don't end, so I should add a dot, dot, dot. Now, do I use the positive or the negative version? The positive. So my answer is x equals 5.38516. 0.38516 dot 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 to indicate that it keeps going on and on. Go ahead and try this one, and I'll give you a hint. The answer is an irrational number. Hit play when you're ready to check your answer. Okay, here we go. There's my dot. I need to lower it down to this spot so that it's at the same height as my second dot. So my target area for this dot to go down to is there. My question is, how much does it need to go down? And help me count. It goes down 1, down 2. Down is negative, so I've got negative 2. So how much horizontal do I need to go? Well, let's see. I go right 1, right 2, right 3, right 4, right 5. That's positive 5. And we can see our right triangle forming between those three areas. My legs are negative 2 and 5. My hypotenuse is my unknown value. The distance between those lines is the hypotenuse, so I need to find the value of x. Here we go. Negative 2 as a square. Do you see the parentheses? That's required. Plus 5 as a square equals x as a square. And negative 2, I'm going to type parentheses, negative 2 close parentheses to the power of 2. Negative 2 times negative 2 is positive 4. And 5 to the power of 2 is 25. And that equals x to the power of 2. 4 plus 25 is 29. So 29 equals x to the power of 2. Take the second root on both sides. And I get x equals a plus or minus, control hat, 2 arrow to the right, 29, and I get 5.38516 dot dot dot. The 3 dots because that's irrational. That decimal keeps going forever. It never ends. It never repeats. But I'm only going to keep that positive version. So x equals 5.38516 dot 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 is my answer. Last problem. Can you find the distance between these 2 points? Your hint again, the answer is irrational. Hit pause, then hit play when you're ready to check your answer. Okay, here we go. I know that I need to raise this dot all the way up here so that it's lined up with my other dot. So I'm going to go ahead and mark that vertical change spot, and I need to see how far up does that dot needs to go. And it needs to go up 1, 2, 3, 4, 5, 6 spots. It needs to go up 6 spots. And how much to the right does it need to go? Let's see. It needs to go over 1, 2, 3, 4, 5, 6. 6 spots to the right is a positive 6. 6 spots up is a positive 6. And there is the right triangle. Do you see it? So my unknown value, the distance between these spots, is my hypotenuse. Let's label that with x. And my legs are both positive 6. So 6 as a square plus 6 as a square equals my distance, my x, as a square. Let's see, 6 to the power of 2 is 36, plus 6 to the power of 2, which is 36, equals x to the power of 2. 36 plus 36, let's see, let's type that sucker in a calculator, is 72, equals x to the power of 2. The opposite of a power is a root, so let's take the root on both sides, the second root to get rid of that, and I get x equals, I'm going to give myself plenty of space because this is irrational, a plus or minus. And let's see, control hat, 2, arrow to the right, 72, plus or minus 8.48528 dot dot dot. Remember the dots. This is an irrational number. The dots tell my audience that this number keeps going without repeating. So, x equals 8.48528 dot dot dot. I only kept the positive version because it's a length, and length should be positive. Good job, guys. Let me know if you have any questions. You are killing it. Keep it up. Bye.